Let's take the very first question. Here it says that if the repetition is not allowed, then how many distinct 3-digit numbers can be formed using the digit 1, 2, 3, 4, and 5? So it's a very simple question. What we have to do is that we have to take 3 places. This place can be filled by 5 ways because we have 5 options. Once one of the options have been exhausted, for this place we'll have only 4 options, and similarly for the last we'll have 3 options. So overall the number of such numbers will be 60. So 60 becomes the right answer. Now let's take the next question. Question number 2. Here it says that the number of 7-digit numbers, the sum of whose digit is 61. Now 7-digit number and the digit sum is 61. It is close to that. More higher digit number or higher value digit will be used. So if I use all 7 digit to be say 9, then in this case the sum comes out to be 63 because 9 into 7 is 63. It's very close. So if I want to make it 61, then definitely I have to reduce the digit by 2. So what I can take is that I can take the numbers say 999 6 times and a 7. In this case the sum would be 61, right? And these numbers can be arranged in 7 factorial divided by 6 factorial because there are 6 same digit, that is 9, and the total number of digits is 7. So overall the number of such numbers is 7. Next, if I want to reduce, I have reduced 2 from this 9. What I can do is that we can reduce 1 from each of these 2 9s. So we can make it 8 each. Thereby again the sum would be 61. Now in this case if I want to arrange, then it would be 7 factorial divided by 2 factorial into 5 factorial, which on calculation will comes out to be 21. Now there is no further way wherein I can have digits 7 digits wherein the sum is 61. So we have to add them and answer becomes 28. Let's take the third question. Here it says that there are 2 identical white balls, 3 identical red balls, and 4 green balls. They are of different shades. So the red ball and the white ball, they are identical, but the green balls are different. The number of ways wherein they can be arranged in a row so that at least one ball is separated from the balls of the same color. Now it says that at least one. So how do we solve it? We take total minus none, right? So let's take the total case, total wherein there is no restriction. So we can say that the total number of balls is 9. So the number of ways we can arrange is 9 factorial. But since 2 of them are identical, we have to divide it by 2 factorial. 3 red balls are identical, so we have to divide it by 3 factorial. This is the total way wherein we can arrange without any restriction. Now next comes when none of the balls are I would say none of the balls are separated, or we can say that the number of colored ball, each colored ball will have a cluster, will have a group, they will be in a group. Or we can say that all red balls will be there, all white balls will be there, and say all green balls will be there. If this is the sequence wherein we are arranging these numbers or these balls, then we can say that none of the ball would be having a different color between it, right? So red ball, we can have only one way of arrangement. The reason being both are identical. Similarly, white ball are also identical, so again we'll have only one way. Green ball we can have 4 factorial ways because all the 4 green balls are different. Further, we can have a different arrangement, for example RWG, or it could be RGW, or it could be WGR, etc, etc. That means in how many ways I can arrange these sequence of the color. So that can be done in 3 factorial ways. So total it would be 3 factorial multiplied by 4 factorial. This is the total number of ways, which is the case of none. So our answer would be difference of these two, correct? So let us do the simplification work. So here this is nothing but 9 into 8 into 7 factorial. This comes out to be 2 into 6. So here it will go by 4 times. Here again it will go by 3 times. Here it will go by 3 times. Minus this is nothing but 3 factorial is 6 into say 4 factorial. Further, here we can see that these two together are 6 into 7 factorial. Here it is 6 into 4 factorial. So we can take 6 common. So here it would be 7 factorial minus 4 factorial, which comes out to be option number 1. Right? Now let's take the fourth question. So fourth question is simple question. Here it says that we have to take the product of all even divisor of this. Now clearly if I factorize 1000, we will be having 2 cube into 5 cube, right? If I want to list out all the even factors, then I have to consider 2, at least 1 in each of these factors. So we can have 2, we can have 2 to the power 1, we can have 2 to the power 2, and we can have 2 and 2 to the power 1 is one of the same things, 2 to the power 2 and 2 to the power 3, right? Further we can take 2 into 5, right? 2 into 5 square, 2 into 5 cube. We can make a with 2 square as well, 2 square into 5. 2 square into 5 square, 2 square into 5 cube. All are the factors of these number as we can see. Further, 2 cube into 5, 2 cube into 5 square, and 2 cube into 5 cube. So these are all the factors which are even. So we have to take the product of this. So if I multiply each of these numbers, then we can say that 2 is, here it is 1 plus 2 plus 3, this is 6, then 7, 8, 9, then we have to add 6 here, 9 plus 6 comes out to be 15, then we have to add 9 again, so it comes out to be 24. So here it is 2 to the power 24. Now adding 5, so it will be 1 plus 2 plus 3 is 6. Here it is 1 plus 2 plus 3 again 6. Here again 1 plus 2 plus 3 again 6. So it is 18 times. So 5 to the power 18. Or what we can do here is that we can take 18 common here. So 2 to the power 18 and 5 to the power 18. If I take common, we are left with 2 to the power 6. This together will make it 10 to the power 18, and 2 to the power 6 is nothing but 64. So we'll be having this as an answer. From the option, we can see that option 3 matches with it. So option 3 becomes the right answer. Now let's take the fifth question. Here it says that find how many distinct 3-digit number we can form by using these digits such that digits are in ascending order. Now this is a very interesting question. We have to keep the digit. We have to take the digit from these 9 digits, but the 3-digit number should have a digit which are in increasing order. So one such number would be say 2, 5, 9, right? This basically matches with the condition given in the question, right? So what we can do is that if I select any 3 numbers out of these 9 numbers, that is 9C3, in each selection I can arrange them in 3 factorial ways, that is 6 ways. But we will find that only one of the possible 6 arrangement, in fact there will be only one sequence out of these 6 arrangement wherein each digits will be arranged in ascending order, right? For example, one of the selection will be 1, 2, 3, right? Now the number of 3-digit number which we can form using these 3 digits is what? 1, 3, 2, then 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. So there are 6 possibilities, but we can see that there is only one possibility which matches the condition, that is the digits are in ascending order. So the number of selection itself will be my answer, because for each selection of the 3 digit will have corresponding only one 3-digit possible as per the condition. So the answer will be 9C3, which on calculation will be 84. Let's take the 6th question. Here it says that A has 24 apples. In how many ways can C share them with B and C so that each of the 3 people have at least 2 apples? So it's a distribution of identical things among 3 different people. So here A plus B plus C should be equal to 24. But the prime condition is that each one of them should have at least 2 apples. So what we can do is that before we start the distribution, we can give 2 apples to each one of them. Thereby, we can say that the sum now left should be 6 minus from 24, which is 18. So this is a clear case of finding the number of integral solutions, non-negative integral solution of this equation, right? Which is nothing but 18 plus 3 minus 1 C, 3 minus 1. So I'm using the formula n plus r minus 1 C, r minus, where n is 18 here, r is 3 here, right? So which comes out to be 20 C2, which on calculation it is 20 into 19 divided by 2. So this is 190. So 190 becomes the right answer for this question. Now what about question number 7? Question number 7 says that distinct 3-digit numbers are to be formed using the digit 1, 2, 3, 4, with each digit use at most 1. That means we don't have to repeat the digit. We have to find the sum of all possible such numbers. Now this is a very interesting question. We can have a direct formula also. The direct formula says that we can take the sum, multiply it with 1, 1, 1 3 times, because we have to create 3-digit number, into n minus 1 factorial, right? N minus 1 factorial. N is what? The number of digits here. So number of digits is 4, so it will be 3 factorial. This is what we have to calculate. This is the sum of all these 4 digits. So if I add them, this is nothing but 10. Here it is 111 and here it is 6. So it is 60 into 111, which comes out to be 6660. So this becomes our answer. Now question number 8. Here it says that an ice cream parlor has ice cream in 8 different varieties. Number of ways of choosing 3 ice cream, taking at least 2 ice cream of the same variety is. So all the ice cream, the number of variety is 8, right? And we have to select only 3 such that at least 2 of them should be of the same variety. So there are 2 possibilities. One, all 3 are of same variety, right? In that case, it would be what? 8P1, which comes out to be what? 8. We can select only one. from there, right? One from each of the variety, and all the three will be of the same kind. So that comes out to be 8. Next is we take 2 of same kind and 1 different than the first one. So 2 of same kind, we can have 8p 1 base, and next would be 7p 1 base. This different would be. So this is nothing but 8 into 7, which comes out to be 56. So we have to add these two. So if I add them, then we'll be getting it as 64, which becomes my right answer. Now question number 9. Here it says that a group consists of 4 girls and 7 boys. How many ways can a team of 5 members be selected if the team has at least 1 boy and 1 girl? So what we can do is that we can have total minus none. None would have 2 cases, which is the group has only boys or the group has only girls, correct? The total number of ways, so is simple. We have how many people? 4 plus 7, that is 11. So 11C5 is the total number of ways. From here we'll minus that criteria wherein all the members are boys. So here it would be 7C5 because we have to select 5 people from the 7 boys, which on calculation we'll be getting it as 441. So that becomes the right answer. Now let's take the last question, that is the 10th question. So 10th question says that a person writes a letter to his 5 friends and addresses the corresponding envelope. The number of ways wherein the letters can be placed in the envelope so that at least 2 of them are in the wrong envelope. Now the number of ways wherein the envelope can go into the correspondingly right envelope is 1, right? Because each letter will go to its corresponding envelope. So there is no variation for it. So there is only one way wherein each letter go into a right envelope. Fine. The number of ways wherein the letter can be put into the envelope without looking into whether it is going into the right envelope or not, that would be 5 factorial, because we can arrange the letter, right? So this is 5 factorial base. If I deduct this one, I come up to the 119. So this should be the answer, because there is no possibility of one letter going wrong, right? If I have A, B, C, D and E and the corresponding envelopes are say 1, 2, 3, 4 and 5, correct? I cannot have a condition wherein only one letter. For example, if A is going into the wrong envelope, then definitely one of these must also be going into the wrong envelope. So obviously a case of exactly one letter going to the wrong envelope is 0. So at least 2 envelope going wrong, that means either 2 or more than 2 letter going into the wrong envelope we can find by total and deducting the case wherein all the letters are going into the right envelope. So this would be the answer. 119 will make 119 is the answer for this question.